everyone. So in this video, we're going to look at cross entropy, and I think I now understand how cross entropy loss is calculated. And for us to be able to go through this optimizing model parameters chapter, we need to fully understand how cross entropy is calculated and everything around it. So I spent quite a lot of time trying to dig through it and gain some insight into this cross entropy loss method. And one of the thing I found really helpful is, like I mentioned in my previous videos as well, I keep going back to these videos of Andre Karpathy. These are just honestly, like, I can't even believe they're here for free. And I'll just tag this timestamp on the this video itself, so you can just go directly to this implementing the negative log likelihood loss, and then how he shows the manual, and then also the how it's written in PyTorch as well. But what I'm trying to do is go even deeper than what Andre has shown there because of my um, non-mathematical brain. So I would like to even dig deeper and just go through the steps here, right? So as you can see, we have a block of code here where one does a a negative log likelihood loss, which is using the PyTorch cross entropy loss. And then I have the second calculation here that does the calculation basically by how Andre has shown on that video, and I also compare the loss. So if we look at the loss that created by the PyTorch method and the loss manually calculated, they are the same. So the idea here is to go through the manual steps and fully understand what's going on. So let's imagine this tensor here is, so these are three images. That means it's batch of three. And then within the three images, we have the probability distribution for four classes, right? So 0, 1, 2, 3, 4. And the class that has the highest probability here is the class that um, the network thinks is the image of. So let's say in terms of t-shirt, so let's look at here, 0.08, 17%, 63%, 7. So 63 is the highest one. So in case of this one, 0, 1, 2. So the second index on this tensor is saying the chances of this being, let's say if the target here says, and the third number here represents a t-shirt class, so the chances of this being t-shirt is high, right? So if that makes any sense. And the rest I ignored because we're going to pluck this value out of here because that's the value with the highest probability, and that's how we classify um, the image here. So we have three image. So this is the probability distribution of one image, and we have three different images here. So these tensor represent image, and each probability is trying to show us the probability of the target class that it's trying to predict. So the target class is those 10 classes that we've seen on the earlier videos, where what we're trying to classify the image as t-shirt, shoes, sandals, whatever. So we have that, and here we have this fake target tensor, which is just for example sake here, so 0, 3, 3. So whatever those targets are, we can refer to. Now what we're trying to do is, if we say 63% chances of this 3 is happening, now is this correct? Like because this is the highest probability here, is this correct? And if it's not, we're going to calculate the loss. So that's the idea. So if it's not correct, what is the loss? And we will see how cross entropy helps us with that. So we have the target tensor here, and if we look at the first step of calculation here, we created an iterator tensor. So I basically printed every single line here, so you don't need to, I mean, you can look at the code, pause the video here, but I'll walk through the tensor and looking at this example, right? So iterator tensor here is the tensor just to help us go through 0, 1, 2, these three tensors. And so we're going to pick the probability by using the target tensor. So for example, here all we're doing is basically we're using the power of torch to pluck out these numbers, right? So if we look at 0, so target, so what we're basically saying is when we are going through 0, 1, 2, we want to pick 0, 0, 1, 3, and 2, 3. So that's how we want to plot the numbers out of this tensor input tensor here, right? So when we do that, what we get is 0, 0 is 0 0.0807, and then 1, 3 is, so here 0, 1, 2, 3, 0 0.43, and then the 2, 3 is 0, 1, 2, 3, 0 0.6093. So that's what we got. Probability picked by target tensor. Now what we're going to do is we're going to get a log probability of this tensor. Now what is a log probability, right? We've discussed the log probability. So if you look at this probability here, 0 0.08, so that's 8%, 8 and some percent, and that's 43%, and that's 60%, right? So as you can see, the log probability, if you look here, the lesser the percentage, the probability is, the higher the number is on the negative side. And also the higher the number is, so in these three examples here, this is the highest number, and if you look at it, this is closer to 0 than the highest number. So feel free to pause the video and just try to understand, and yes, please, again, just learning all this and just trying to clarify my learning by creating these videos and explaining everything. So if you think something is off, please feel free to raise a comment, and yeah, I can look further into it. So yes, just to go back to it, we have probability picked up by using the target tensor, and we have the log likelihood of this probability. Now log likelihood, log probability are very interesting concepts, and I'm just going to quickly show on this ChatGPT example, which I really like. I did show this on a previous video, but I think it's important to just go through this and fully understand it. So what it says here is basically you want to see how is your trip, how will be your trip. There's a 30% chances of rain, 20% chances of heavy rain, and a 10% chances of car breakdown based on your car condition, whatever, right? And now what it's trying to say here is if we use these probability and multiply them, we get very small probability number here. And this probability number might not be easy to work with because of this small precision and losing a value of the actual number over, that's where yeah, like precision error or calculating or making comparison, it's very harder. It starts to get difficult, right? So instead, if we multiply the probabilities, you can take the logarithm of each probability, so we can get the log of this probability. And then so what we get basically when we get a log is log of that, log of 20, and log of 10. So we get negative 1.204, which is much easier to understand than 0.0006, right? So that's just saying your trip will likely be pretty bad. Like the chances of bad things happening on this trip is very high. So it just log probability helps us, makes the number much more readable and much more meaningful, right? And what we are doing here is we get the log probability, and we get that on negative, right? So and then we turn that into, so we get all that and we turn that into the mean of log probability, and then we just turn that into a negative, so positive number. And what it does now is, if you look at 1.28 is our total loss on this one iteration of whatever we did right now. So if we, so the goal of the network is to minimize the loss. So these probabilities up here are much more accurate by minimizing loss. So 1.28 is not a bad loss, just in general, I think. But you would want to get much closer as much as you can. So I hope that was helpful. And you can jump into how the log probability is calculated. And it's quite a complex calculation, but I guess we also need to draw a line, like where to stop deep diving. So I'm going to stop deep diving here, and I understand what log probability gives us, and I think that's enough for now. I hope that was helpful, and I hope I made some sense. And yeah, if you are also learning, please feel free to share your journey while learning a neural network. Thank you.